Good afternoon, Professor. I have a trees assignment here uh, in three files. And here's our header file uh, with our functions defined, declared. Uh, and and so we have our binary search tree class in a template, and we have our node encapsulated a private. Here we have declared our functions for that and a public binary tree BST constructor here. So here we have our functions defined, including our header using standard namespace, using namespace standard std. And so we're using this hard-coded demonstration, um, start to finish on a single run, just to demonstrate how to navigate through a BST right here, creating the object, and then right here some the array, uh, some hard-coded numbers with a couple duplicates to run these functions. Uh, Going to deliver the output statement just to give it, make it clean, share an idea. This has to do with a real world example of shipping containers. So the real world example that I'm using has to do with shipping containers for the ports of any shipping port, how these numbers would come in into a system, and then how we would displace them in order. As you can see right here, this function calls for that. Uh, and then we will remove from a BST from the BST, and we remove a leaf node, specifically ID3. We'll remove a node with one child, two children, and here's uh here's our error if the list is empty. Try catch uh, exceptions or error handlers. So if we call to demonstrate, if we call for to organize these, um, to set them up and organize them, we're going to call the insert ID function, which is right here, and this calls the insert helper, which is our main function right here that will I will put it in order. It creates a new node since the list is empty. It'll start with the root node, and it'll start allocating our values to the left if the value is less than the node's value that it's pointing to at that moment. Else if uh, checks it to the right, and unless there's a duplicate, it'll throw our runtime error. It'll throw a runtime error indicating that the duplicate value and and it could not be inserted. So then we remove a function right here using the delete helper. We'll just go down main. Uh, Here's a traversal function in order traversal. I use double new line characters to give better so it looks cleaner, more space. A traversal, function here in order traversal. Uh, we set up with our vector. We call this in order traversal helper right here, and it'll it'll keep checking the node to the left till we get to the end. It'll send back the value, and it traverse to the right after. By doing that, it naturally propagates back up the tree, assisting in the recursion function with the recursion function. So that helps the system rather than allowing the compiler to do it itself. Um, it just naturally occurs. Um, does it help? Millisecond, maybe? I mean, a gazillion second? I don't know. I didn't look that part up. But yeah, we got to call it explicitly since it's a template, as mentioned in the last. Uh, and so here's our function to check if it's empty. We use 99 to verify uh, that it's empty because if I call one of these, I can't, right? So I put in 99 to call from the function here, from the hard-coded function. So it so I could test it. And here's where to go. Um, right, empty tree. Remove 99. So remove a leaf, remove three from three. Once I run it, you'll see that three will no longer be there. Let's see. Remove three. Here's our list. Uh, here's our list. Three's right there. Three's gone. In order after moving three. That's our output to demonstrate that it is gone. New line, new line. To give us our space to make it look clean. Here's a second child, 45. Remove 45 out right there. Maximum container ID, 100. And that is the max that it calls. Max function right here. Uh, Max value. No, that's not whatever. Um, right. Is empty calls a is empty function maximum. There we go. Here's our maximum. If null, then yes, tree's empty. If not null, it goes to find the max root right here. Well, there is a node and there's a node available to the right because to the right is going to be our maximum. It will continue until we find the max value. It'll return that node. And that was the last example. Uh, End of demo. Um, thank you. And stop recording.